Welcome back. Today we're exploring an important feature of the JAX framework called automatic vectorization. To begin, we'll need to install the JAX library with TPU capabilities. JAX is very versatile because it can run on any type of hardware, whether you have special accelerated hardware or just a regular CPU. Let's first understand why vectorization matters. When we process data, we often need to perform calculations on many items at once. Without vectorization, we have to use loops to process items one by one, which can be very slow. Vectorization helps us make these calculations much faster by processing multiple items simultaneously. This is especially important when working with matrix operations, which are common in machine learning. To demonstrate this, we'll start with the basic example using manual vectorization in JAX. Consider two vectors, vector x and vector w. These could represent inputs and weights in a machine learning context. We can perform what's called a convolution operation between these vectors using dot products, which means multiplying corresponding elements and adding them together. For our manual vectorization example, we'll use JAX's NumPy stack to create something called a batch. We'll take our vector x and make 50 copies of it to create a batch of 50 entries. We'll do the same thing with our weights vector w. When we print these out, we see long sequences of repeated vectors. This is just to help us understand the concept. Now let's try processing these batches using what we call the naive approach. In this approach, we simply use a loop to process each pair of vectors in our batch one at a time. The loop goes through the first dimension of our vectors, and since both our input vectors and weights have the same batch size, we can compute the convolution for each pair and save the results. When we time this naive approach, it takes about 80 milliseconds to complete. We could try to speed up our manual approach by setting up more complex vector or matrix math operations, but this would make our code more complicated and harder to maintain. However, even with basic manual vectorization, we already see a significant improvement in performance compared to processing items one by one. This is where JAX's true power becomes apparent through a feature called automatic vectorization, which uses something called vmap. To demonstrate this, we'll take our original convolution function that we defined earlier and apply JAX's vmap to it. When we time this automatically vectorized version, we see that it processes much faster than our naive looping approach. When comparing these two methods, manual and automatic vectorization, the automatic approach is clearly superior. It's much simpler to write and easier to understand. This makes our code more maintainable and less prone to errors. It's helpful to understand how vmap works behind the scenes. When you use vmap, it examines your function and automatically adds what we call batch axes to each input. Think of this as JAX automatically figuring out how to process multiple items at once in the most efficient way possible. The benefits don't stop there. Automatic vectorization works seamlessly with other powerful JAX features, particularly the just-in-time compiler. When we combine these features, we see even more dramatic speed improvements. This means we've transformed our slow, basic batch processing into a highly efficient, streamlined operation using automatic vectorization. There's an important technical detail we should mention. Based on how JAX does asynchronous dispatch, meaning it can start new calculations before others finish, we probably want to include block until ready in our timing measurements. The computation time is pretty minimal for these examples, but we should be consistent in measuring the full time, not just the dispatch. The trends are nevertheless the same in this case. Looking at our journey, we started with the basic loop-based approach that took about 80 milliseconds. Through the power of JAX's automatic vectorization, we transformed this into a much faster and more elegant solution. The progression shows how we can move from simple, understandable code to highly optimized implementations without sacrificing readability or maintainability. If you'd like to support the channel, consider starting a free trial of our new design tool, which is linked in the description, and let us know what you think. We'll include a link to the JAX documentation in the description as well. If you have any questions, please post them in the comment section, and we'll do our best to respond. Thank you very much for watching to the end, and please enjoy responsibly.